Hi students, I hope you are enjoying this wonderful weather in this weekend. Some students are being asking whether there will be assignment of problems for this first part of the class. As I mentioned in classes from the beginning, the first week of class is very light in terms of homework. The material doesn't require a lot of homework, but we are going to have lots of homework starting next week. So on Tuesday and particularly on Thursday, you are going to see the homework coming. And I hope that you catch up with this homework. Don't let it then accumulate and go step by step. But many students are contacting me and they ask if you had any problems, any other assigned problems for this weekend. So the material that we covered this was not very intense yet because it's the first week of the class anyway. However, since you are asking, I thought that I would share with you some of the questions that came in previous exam relate to the material that we studied so far. And when I look at the first midterm exam of 2025, that was the class that when I taught this class for the last time. As you know, I only teach this class once a year in the winter quarter. So I look at the exam, there were 4 problems related to the first week of class. And these are the problems that we could look at that right now. So I thought that I would give this live and hopefully it goes well. I have been working the whole weekend to try different softwares and they were not being working, but finally I find something that might be working. I'm not sure that the broadcast is continuous or not, or it's being interrupted. In any case, I'll try. And what I'm going to do now is I'm going to share a screen and share the exam for last year, the 2025 exam, okay? So let's do that. So as you see here now, we have the first midterm for 2025. And every time that you get an exam in my class, you are going to have a QR code, and we're going to have that we use the QR code for attendance, right? You also for the exam, whether we take the exam with the entire class or we take separately for students that have a special requirement, everyone should scan this QR code, okay? And the first thing we should do when you pick up the exam, don't try to get excited and read the exam, just look at the instructions here and make sure that you write your name and the ID, and you write your name in all pages. The reason for that is that we're going to be scanning these exams, and when we scan this exam, we cut them apart. If something happens that you don't have your name in all pages, we may not know that this is your exam, and they may assign that to someone else. Okay, so first thing we do is like that is to write your name in all pages. Page 1, page 2 is going to be the reverse of that page. Page 3, you write your name. If there is a page 5, you write your name as well. Okay. And the instruction here from last year said that you don't use pencil. I'm going to waive this thing starting this year. I'm going to let you use the pencil, but it's going to be your responsibility that you write strong enough that the scan can see your letter. Because if you cannot see your letter there, we are not going to be able to grade the exam, and we cannot do that after the fact. Another thing about my exams is that they always come with a good luck and with a data bank. The data bank, that's where I put information, and there is more information that you might need. Okay, so everything is here that you may need, and it may be more. All right. So, for example, the R constant is going to be here, and dissociation constant of some acid and so forth. You take all the information that you want from here and use it for answer your question. And the first question of this exam was worth 5 points. And you can't imagine how many people got this question wrong last time. And I wanted to avoid that the same thing happened again. So the question says, Ozempic, which is also known as semaglutide, and the glucagon-like peptide 1, GLP-1, the molecular formula for these are C187, H291, N45059, and C149, 8226, N40, O45 respectively. if an Ozempic injection pen of 0.7 milliliter contains 0.5 grams of semaglutide of Ozempic, what's the molar concentration of the active ingredient in Ozempic pen? All right, so this is just asking you to calculate the molarity, which is equal to the number of moles divided by the volume in liter. However, we don't have here the number of moles, so that we have to calculate the number of moles. So the way to do that is that we can also use the formula that's the number of moles mass divided by the molecular weight, and the volume that in liter that was there, you will repeat it here. So I don't have the molecular weight of this compound. So the first order of the day would be to calculate the molecular weight of Ozempic, right? So how do you calculate the molecular weight of Ozempic? First I go here, there are two forms, and this is typical of my exams, is that to help you with the critical thinking, to pick up the information that you want, not to get confused. When you become a medical doctor, people is going to come to your office, is going to tell you stories that nothing to do with the presentation of the disease that you are trying to assign, and then you have to get away with this information that are unnecessary. So here we have two formulas that speaks about two different compounds, and the first compound is Ozempic. So Ozempic is C187, H291, O45, N45, O59. So let's do like that. First, we're going to say 187 times the molecular mass of carbon. We go in the table there, and it says carbon atomic number 6, atomic mass 12.001. So we are not interested in atomic number here, we are interested in atomic mass, so times 12 plus H is 291. Hydrogen, we don't need it to go in the table there, that's 1, right? But if you don't know, go in the table and you get that. And the nitrogen is 45. And what's the atomic mass of nitrogen? We go here, there's atomic number. If you take that, you are going to get it wrong. And there's the atomic mass of nitrogen, which is 14, so times 14. Plus the oxygen now, which is 59. Times what? What's the atomic mass of oxygen? Atomic number is 8, atomic mass is 15.999, so essentially 16. So now I have the calculator here as well, so I'm going to do all of these. 187 times 12 plus 291, 45 times 14 plus 1960. I got 4,000. This is a little bit mess because I'm writing this thing on the street here, so that's a little bit mess. But I got 4,109 for the molecular weight of this compound, this famous compound now. Now I can calculate the molarity, which is going to be equal the mass that we have of Ozempic is 0.5 milligrams. So 0.5 is because it's milligram. I'm going to 10 to the power of negative 3, right? Because that is milligram. And divided by the molecular weight, I just calculate the molecular weight, 4,109 times the volume. So the volume of this pen is 0.75 milliliters. So I'm going to put here 0.75, but I have to put in milliliters. This is in liter, the formula, so that 10 to the power of negative 3. Negative 3, this is a common term here. We can get rid of that. You don't need to put that in the calculator. In the calculator, we are going to put 0.5 divided by 4,109 divided by 0.76, 75 actually. That's going to give us 0.12316 something. I'm not going to go write all the thing down, okay? 1230. So this is going to be in molar. Then I change in here 1, 2, 3. This is going to be 0.16 millimolar. Make sense? So it's an easy problem, but it would need a little bit of a refresh things that you have done probably earlier on in your life in high school. All right. So this was one problem. There's actually more problems associated with what we did in this class in this week. Problem number 4 for that exam. I skipped the other ones that I'll show you later. SARS-CoV-2 is a killer that's not even alive. Why? Name at least one property of living systems the SARS-CoV-2 virus does not fulfill. So we talk about 4 properties of the living system, right? We talk about the complexity and the other things, and then we talk about the 2 of them that they are not, virus do not fulfill, therefore they are not considered living entities. One was with regarding to energy. They are not actively transforming energy, right? Our cells that are alive, our cells are actively transforming energy. You eat, and then we need the energy supply there. It's going to change, it's going to burn these calories, and it's going to generate ATP. ATP is going to produce, degrade somewhere, and release that energy. But the virus do not do that. And another property that's even more important is the self-replication, right? They can't replicate by themselves. They are sitting there waiting for a host cell to be able to hijack the system of host cell and replicate. This kind of questions name at least one property. So at least means one. Do not try to do too much, because if you get it wrong, then you are going to get graded for that, okay? So I would say they do not have the ability to self-replicate. Self-replicate. I'm not going to write the whole sentence in here, okay? Self-replicate. They do not have the ability of self-replicate, which is a very good ability that all living entities have, right? So they can, we talk in class about it. We gave an example of the aphids that are so remarkable in terms of reproduction and self-replication. All right, I think we got that. Number 5 would be a question worth 6 points. And it said, in the 20th century, 3 influenza pandemics occurred. The most devastating one was the Spanish flu, H1N1, which caused the death of 50 million people. In 1957, Asian flu H2N2 was responsible for more than 1 million deaths. Next, the H3N2 Hong Kong flu in 1968 resulted in 0.75 to 1 million deaths. Explains what are the terms that are presented here and what they mean. This H and N. What do they mean? So these are 2 different terms that we have, and we talk about this. Those H and N are proteins, correct? You could say that these proteins are also spikes. That's fine. Especially the H is a well-known spike. N is a spike-like protein, right? So what are the names? This hemagglutinin. One is hemagglutinin, and the other one is the neuroamidase. And neuroamidase. Right? So these are the 2 of them. And what's the term refer? This index, 1 or 2 or 3, for example, this index here, H2 and 2, it means that they have the hemagglutinin type 2 and the neuroamidase type 2 as well. This one here would have the hemagglutinin type 3 and the neuroamidase type 2. So we're going to say the index or refers to the type of protein, right? So that, or they can say the type of hemagglutinin or the type of neuroamidase. Okay, so that's what it is. Lastly, for today, there number 6. You see there how many points were in the first midterm exam, even if you didn't have much work assignment. The last time you got a complimentary glass of water with ice in a restaurant, the ice cube were floating. Explain based on hydrogen bond why it did not sink. So that was a thing that we mentioned in class very clearly. We discussed that in class, and we explained why glass is floating, because they have a lower density. But just saying that it has a lower density would not be complete. It would not help if we explain your understanding of the hydrogen bonds. So what we have to say is that because of in the solid state, in the water, in the ice, they form 4 hydrogen bonds, and the arrangement of the hydrogen bonds causes so much empty space that the volume is larger than the same amount of water molecules in the liquid stage, because in the liquid stage they are more compactly arranged, right? So they generated this space, they created this volume, and they become a little bit larger volume relatively to the same mass. So therefore, the density decreases. And the density decreases, they go up because they are floating. The density is higher, they go down, right? If you mix up water with dichloromethane in the lab, dichloromethane goes to the bottom because it has a higher density, and that's how one way that we separate things. Okay? Another example of a hydrogen bond is that sometimes I come to class, I don't know exactly what I'm going to say, but when I left last time, I regretted that I didn't remember to say something about the hydrogen bond. One premier example of hydrogen bond is we use a tissue paper, right? We have water, for example, dump a little bit of water on the table, and then we put the tissue paper, immediately sucks all this water, right? The tissue paper is made of cellulose. Cellulose is rich in hydroxyl group, or H groups. So water likes to make hydrogen bonds, right? And then cellulose is there, they suck. That's very easy to get absorbed. So I hope this would be helpful, and I'm not sure that it is, went through or not, because like I said, I'm testing new softwares and new ways of communicating to you throughout this quarter. Stay well, enjoy the rest of the weekend, and I look forward to see you on Tuesday. Bye-bye now.